Okay, so it's Tuesday, August 18th. We're on lesson 1.2. Before we do that, we're going to look at number 8 on homework 1.1. And on this problem, this is probably the toughest problem that exists in this particular homework. You have to come up with a class range, which means you have to define a width. And then you have, in the relative frequency or the frequency period, that's pretty easy to do, right? So here's what you have to do. There's a calculation that you can do that will make your life a little bit easier. And you don't have to sit and guess, okay? So what I need for you to do is find the low number and then the high number. Okay? So what is my lowest number in this data set? 22. What is my highest number? 65. Y'all agree? Okay, so 65. What you're going to do is you're going to do a simple calculation called the range. Okay? So you're going to find the range. The range is taking the highest minus lowest, right? Which is 65 minus 22. That will give you anybody? 43. Now, that is your span of your numbers from your lowest to your highest, right? But the really good thing about this is it makes this life a whole lot easier is it already tells you how many intervals you need to have. So if you count 1, 2, 3, 4, 5, 6, so you're going to take this span, this range, you're going to divide it by how many intervals that they want you to put it in. Now, I know and you know that 6 is going to 43, at least 7 point something, right?
So you just round?
7, no. Well, yes and no. It'll be 7 point, I don't know.
It's like 8.
No, it ain't 8-7. It's close to that. I'm going to say approximately 7.1, right? Is that okay? Now, we're not going to round it down. We're not going to use our rounding principles as to say 4 down stays around 5 and that goes up, right? That's the rounding principles that you normally do. But if you have a decimal period, it's going to always go up to the next whole number. Okay? So your width, it's not going to be 7.1. It's not going to be 7. It's going to be 8. And so my width is 8. Now here's what you need to consider. There's one guaranteed box that will always be a certain number. And that's this one. It has to be your lower bound, 22. Okay. From there, now all you're doing is this. 22, 23, 24, 25, 26, 27, 28, 20 what? Thank you. Right?
Oh, wait.
That counting when you start with, right? Okay, so now we go 30. That's why I'm using my hands, right? Y'all can't see it on video, like, because it ain't picture me, but you can hear my voice. So I'm counting 30, 31, 32, 33, 34, 35, 36, 30 what? 37. Right? So the next one would be what? 38. Now, you would think that the last one, this little last box, would have to be 65, right? It don't gotta be. That's exactly one way to put it. I like it. You can get it clear. It ain't got to be. You understand me? Like it don't have to be right there. So the only box that has to be is this box right here. That has to be your lower bound. And you just fill in the rest based off of your class width, right? Is that okay? Does it make a little bit more sense? Now that problem that seemed really, really tough is now what? That's it. It's all in how you think about it and understand how to do it. Once you understand how to do it, then I can put how many problems like this and you'd be like,
Wait, but how did you get the 8 from the 7.8?
you always, if that did not come out to be 7.0 or 7 period evenly, like goes into it evenly, like a multiple of 7 or multiples of 6, I should say. 43 is not a multiple of 6, 42 is. So you know it's 7 point something, right? So therefore, it can't be 7. It has to be what?
8.
You got to go up. If it gives you a decimal, whatever, 4.3 something goes to what? 5. 6.2 goes to what? 7, so forth and so on. 9.8 goes to what? 10. You're
So-
going up. You're not going down. You're not using your rounding.
Caleb did that thingy, and he got 10, like straight 10, so he would just use 10.
Yeah, if his class was.
But his last number is 74, but he has a 75 in the box.
What did I say about the last number? Tell Mr. Beck.
So just count that out.
Mr. Beck, tell him what we say. It ain't gotta be.
It doesn't have to be.
This last box right here is gonna be, it's gonna be what it's gonna be. What's the guaranteed box that has a known in it?
Then you just won't use that.
That's right, that first one, right? Y'all feel it? You with me right now? Y'all see it? Yeah?
In between those.
Hey, now, like preach, bro. Come on now. Yeah. All right, good. I like it. Y'all just get prepared to. This is great. All right. Any questions? Any? I know we've got to take this kind of but think about what the conversation we're having. It's going to stick because we had a conversation about it, right? Yeah, we do a little bit of fun in it. That's okay. We can cut up. We whatever. We can say it like Jackson County tile. You know what I'm saying about right there? We can do that right there. Yeah, but it's whatever it's going to take to stick. Now, any questions? Okay, ladies and gentlemen, let's go on to our today's lesson. And today's lesson gets into 1.2, right? 1.2 is analyzing one variable data, displaying categorical data. We did categorical and we did what on 1.1? Quantitative. What's the difference between categorical and quantitative? Give me one rule of thumb. Quantitative, you can find the average. A categorical, you can't. You can't find the average of purple, blue, or yellow, can you? No. Categorical is a category, right? So we're going to talk about some really simplistic ways that we have displayed categorical data in our lifetime, starting in much back as 3rd grade. You go, well, I was barely able to get to the lunchroom in the back without wearing my lunch. That's true. And when we did that, we called that a successful day, right? So, yay. Now, in this lesson, we're going to understand, I told you it's the 2 simplistic ways, right? We're going to make and interpret bar charts of categorical data. I'm going to get you to understand that based on 1.1, we looked at statistics is looking at the story of the numbers, right? That's the definition I gave. Would y'all agree? Okay, so we're going to look and we're going to tell what the story says when we look at a bar chart, pie chart, and we're going to identify some graphs of the categorical data that is deceptive, right? Deceptive, right? Huh? No, not right. Okay. All right, so I'm going to pause it and let you write down the 2 vocabularies. Bar chart and what? Pie chart. Yes, you need to copy those down. So, when you look at a bar chart, make sure that the horizontal axis is already fixed because that's going to be your categorical data. Your vertical axis is going to be either a frequency, that means a count, or it will be a relative frequency, which is a percent. You need to make sure that you denote which type it is, okay? Pie charts. Pie charts, guys, we've done these, right? They are, for the most part, always in terms of a percentage, a relative frequency, right? Percentage of it. Now, I want to ask you this question. When you look at bar charts, when you get pie charts, tell me the one thing that you clue in on. The one thing that is automatically first received in your brain. Huh? Colors. You going down the right road. You're dancing all around that campfire and then just jump in. Come on. Feel the burn. You close. What do you think it is? What's the first thing? And you probably haven't never thought about this, but you do it, huh?
The size of the pizza.
Huh?
Size of the pizza.
The size of the pizza?
Like the slices.
The size of the pizza. Alright, y'all, you know, that's a really good description, and thank y'all for sharing it, but y'all are absolutely correct. You key in on two things. You key on the color and the shape. And the shape is how big the slice of pie is, right? That's the two things. You don't even look at the numbers when you look at it first off. That doesn't even come into your thinking. The first things that you look at is the shape and color. Because they're all inclusive, right? That's so we look at it from a visual standpoint. That's how we picking up our eyes or brains analyze it from a visual standpoint. Even so for a bar chart, we're not even considering the scales, right? We're looking at the bars compared to one another, just like the slices of the pie. You're exactly correct. So just consider that. We're going to get you to also look at the data and what story does it tell, right? You with me?
Mhm.
Okay, good. Now, I'm not going to go into, I don't need you to copy down this. Okay, we all know how to make a bar chart. But I'm going to recap it, and here's my recap. Horizontal axis is always categorical. Vertical axis will be either a frequency, a count, or a percentage, a relative frequency, right? You get to choose the scale in which the vertical axis goes. Fair enough? You get to. Now, so yours could be different from each other's, but still be correct. Now, there are ways to do a scale that you would look at it and go, I'm not sure I would use that number. A scale can get really busy on the side. If you put it in too small of an increment, all you're seeing is a bunch of, you can't start to discern what is it, right? So you need to have as good as a resolution that you can so that you can interpolate if it's between. Does that make sense? Do you understand what I mean by resolution?
Mhm.
It's like the zoom in, zoom out. Do you have enough of a span that if it falls between it, that you can accurately interpolate where it is within some reason? Right? Okay. Questions on this? So things to consider, right? Sweet. Okay, so let's look at this, because I love this example, and I want y'all to see something, because this is pretty cool. We have the level of education, boom, that's categorical. We have the percent, that is already in relative frequency, right? So let's kind of look how they decided this. This is fixed. I told you that the horizontal would be fixed, right? Now, note the vertical axis. Did they pick a really good scale based off of, look, it's 10.6, 24.9, 28.7. We have a lot of decimals, right? Did they pick a suitable scale for the vertical axis? Would you have put decimals in that vertical scale? Yes or no? No. You don't need to. You could tell that this right here is probably right around, this first bar is probably right around what? 13 to 14, probably up closer to 14, right? Would y'all agree? Based off where it is. Well, look, what is it? 13.2. Okay. You're in the ballpark. You're not going to be precise on a bar chart. Do y'all understand me? So there's room for error. Pie charts, precise, right? Voila. Bar charts, interpolating, you're going to get in the ballpark. Ballpark. Right? There's a difference. You don't need to be like in the country and think you close enough. You need to be in the ballpark, like that specific place, close, right? Yeah. Can't be in the city, you need to be in a location, right? You gotta be like that. Any questions on that? Note that how it's labeled. It's labeled as what? Percent. So it's not a count. So here's my question. How would you take a percent? If I told you that this data was taken from 2,000 surveys, how would you get back to the count? Oh, I did. I asked that question, didn't I? How would you get back? Because they give you relative frequency, right? Relative frequency is the result of a ratio between part over whole, right? If I told you 2,000 people there, right?
2,000 times percent.
2,000 times the what? Percentage, right? If you think about this. So if you go X over 2,000 equals some percentage, right? Y'all remember that little cross multiply thing? Y'all remember that? If you do the cross multiply or just multiply both sides by 2,000, you get X is equal to 2,000 times a what? Percent. But that percent needs to be as a what? It's a kicker. It needs to be as a what?
Yes.
A decimal, right? Do you see what I'm talking about? So there's a lot of things that you could go back to based off of that. Now, you probably have a little bit of error, right? Okay? You mean just a little bit. You may come out, oh, what I do is it come out as a decimal. Well, it shouldn't. Because, well, I didn't say it shouldn't. If you round it off on the percents, what did you just introduce? See these percentages here? There's a 1 decimal, right? So what did you introduce? Error. Know what I'm saying? Error, right? So when you go back, if you come up with a decimal as a person, then you know that that has error, right? So you need to consider that when you're going back. All right, any questions on that? Y'all good? Man. Okay, look at that pie chart right there. See them slices? 3 people were eating really good, right? Some hefty eaters there, right? Yeah. And then you got 2 people like, yeah, I want a small slice, right? Small slice here. Now, my question is this the same data that we just used? Okay, well, let's change back. You see this? Like these 2, like less than high school and advanced degrees, they were the smaller of the 2. And then these 3 were pretty close in proximity, right? But the some college was more than the others, right? We look at it in the pie chart. Does the yellow appear to be bigger as much as it does on the chart, bar chart, than the other 2? Yes or no? Kind of and not really. It's a little bit deceiving, right? If the percentages were not there, you'd be like, they could be pretty close, right? But you've got, I don't know, 3 to 4% here, what, about 5 to 6 there, depending on how you subtract it, right? So don't hold me to it, but it's pretty close, right? So, and then there's that. So, any questions thus far? Pie charts are normally done in percents. You with me? Y'all tracking? Like y'all ain't sitting over there doing homework? Like, that's because I'm supposed to be doing. Where your notes at? Okay, until I had to chase a rabbit, fix nothing. I wanted to show you some deception that could happen because, you know, we could deceive you. And this is how you could be deceived on a bar chart. Instead of taking this little, let me show you how to be deceptive. You know, I ain't talking about cheating. What if I took away those scales because it started at 0? What if I changed it and made that joker right here like 10, you know, I don't know. I don't know, 10. I know it ain't gonna work out for this, but what did I not do? I didn't start at 0. I started at a higher point, which is going to affect the height of my bars, right? Does that make sense?
Yeah.
So that's how you could be deceptive. See, what we do is our first thing that we look at, we normally look at the bars or the shades, right? We're comparison. We then and maybe then we look at numbers. Then we start looking at numbers. Pay attention to that scale because they can fool you mathematically. Big time. It ain't funny. They can mess you up. They can make you draw a conclusion or a misrepresentation. You've heard the saying that you can make the data look and appear any way you want to. Yep. There's people who make a living in doing things to make it accepted, to make it appear to be exactly what it really ain't. Okay? So I need for you to be wise beyond your years. Take a step back, understand the story. There's a story being told. Okay? Now, here's the real cool thing that the bar chart has on the pie chart that pie chart can't do. The pie chart can only handle one category as far as one grouping. The bar chart can handle, guess what? Multiples. Now, you say multiples. Right now, this is 2, right? They looked at this right here, relative frequency, boom, 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 boom. They looked at superpowers with respect to male and female. Yes, they took a survey from Marvel. They looked at this and this. So they compared male and female per each category. You can do that. So here's my question to you. How many comparisons can you have on a bar chart where it makes it useless? How many comparisons between these different categories within the category can you look at and it make it useless?
More than 3.
I wouldn't go more than 3. You can have 3 and probably, it may get a little busy, right? But 3 is pretty safe. That would be a rule of thumb, a max that I would look at. So good answer. You get to 4, then all those things kind of look like, well, am I looking at a whole separate bar chart compared to the whole thing, right? So you've got to kind of think about that. But most of the time, 2, maybe 3, right here, right? I could do something like this right here, right? Tell me one little feature about bar charts that you must understand that would just make them differ from a histogram. Because histograms are bars, right? Histograms are bars. So we're going to do histograms. But a bar chart, the bars in the categories do not touch the other category. Do you understand? There's a distinct no man's land. And when you get more than 3 of them in there, then that starts to make that where they all run together. We don't do that. So I signify a third column by green, right? But I tried to leave a space, right? You see my space? It wasn't the best representation, but you at least get the point, correct? Yeah? Good? Yes. All right. Any questions? Sweet. Did you ever think there was that much to know about pie charts and bar charts? You thought you knew everything about them, didn't you? Huh. Until today. Now, here's some do's and don'ts. If you look around this room, you can tell that this is a male teacher's room. Why?
Some decorations.
So you can go down to Miss Johnson's room and there's football.
No, that one.
Yeah, that's too. Football. Miss Johnson has football in here too. How can you tell that this is a male teacher?
There's not a lot of decorations.
Well, there's a male teacher standing there, right? Yeah. It's the obvious. No, what if I wasn't in here? How can you tell that this is a male teacher?
No decorations.
It's the bare minimum. There's no frou-frou fra-fra, right? You see what I'm saying? There's nothing cutesy. I hate to say cutesy, but come on. So, see this chart right here? Look how cute that is. It's got a donut picture right there. And it has Pete's picture right there. Ain't that so cute? Boy, that sure does represent that day a lot, don't it? You could tell a lot about that right there, can't you? No.
That pasta's pretty nice.
Huh?
That pasta right there.
That pasta, we call that right there? Huh?
Come on.
What type? Angel hair pasta.
That's pretty
Yeah, it's really thin, right? That's the really good type that you use for spaghetti. The angel hair pasta, not the regular, not the thin.
What about the extra thick,
The what?
the extra thick noodles?
No.
Pretty nice.
I don't like it. What about ramen?
What about ramen?
What about the cinnamon?
What about it? I don't know. All right, so there. Here's the same as bar chart. Do you see the difference?
Yeah.
Do you see how the donut, you really can't tell much between the donut pizza, right? And the thin piece of angel hair pasta there. It's like, woo! But you can now. The donut does not look as big as what?
The pizza.
The pizza when you look. So misrepresentation, right? Don't get cutesy on me. Keep it simple. Kiss method, right? You know what the kiss method is, right? Keep it simple.
No.
Well, some people put the extra S on there. Silly. Some people say stupid. Some people say other things, but keep it simple. Don't, look, in math, you're telling a story. In stats, you're telling a story. We're not putting rainbows and unicorns in. It's the bare facts. It's like this room. It's the bare minimum, right? We ain't getting cutesy with it. Don't get cutesy on it. Okay? Now, y'all ready? Don't do 3D charts. You know why you don't do 3D charts? Those look really good. A lot of businesses use 3D charts. Okay? They're cute. They look good. But sometimes they're hard to read. They could be misrepresenting stuff because of the way they store some of the news. Keep it two-dimensional, flat. Right? All right. Now, here's what I want you to do. This is 1.2. This is you doing stuff. So we're going to look at cell phones. And they just took a survey of 2,024 people. And they said, how many of y'all like or have iPhones? How many of y'all like Androids? And how many of y'all like others? Now, others is including smartphones. Others are other types of phones that are not smartphones as well, right? Y'all understand? Okay, so what you're tasked with making a bar chart. Okay, so I'm going to just shut up for a second. I'm going to close my mouth, as hard as that can be from time to time, and I'm going to let you do a bar chart. Now, notice that you're going to do it by hand, so therefore, it's not going to be to scale. But the information that's on it should be accurate. Does that make sense? Okay, so go. Okay, here we go. The categories on the horizontal axis cannot what? They can't what? No, they can't touch, but they don't change. So we have what? We have iPhone, Android, right? And then we have what? Other, right? We have other. All right, so those are fixed, right? That would be what? They all fall under a thing of what? Types, right? That would be the title of it, types. Those would be categories. Any questions about that? Anybody? Yay, nay? Okay, good. Now, over here, we have the scale. Now, it goes up to how many? 1,054. Do you want to go straight up and make the very top 1,054? No. You want to make it a little bit higher. It's kind of like canning. When you can food, you leave a little bit of headroom, right? You gotta leave a little space up top. Okay? So what I'm going to do, I'm going to do this, and let's see if you did the same. Make your tick marks evenly spaced. I'm going to start at 200, 400, 600, 800, 1,000, and then one more at 1,200, right? I stepped mine by 200. Is mine correct? Well, it's one correct representation. What's another correct representation you could have done? You could have done 100. Your tick marks would have been a lot more, right? But 10 tick marks really aren't going to get crazy, right? I probably would drop it below 100 because then you have increase. You don't want the amount of tick marks over on the side to be so busy that you misinterpolate what you're pulling from it, right? So you could have went 250, right? That would have been the span of that. So anyway, iPhone's 467, so Android 503. I know it's not the scale if you go across, and then 1,054, right? Okay, there. Right? Do you see that? Does that represent the table, that the relative frequency table that we got? Yes, no? Okay. Now note that mine is not the scale, and probably neither is yours, right? If you do it by hand, then you're gonna run into that. But your axes, your stuff, your naming and stuff like that, that's critical knowing how to do that. Okay, you can get a little bit more exact and precise if you use programs like Excel or Phantom or SPSS, statistical and software. You can use Minitab, all this other stuff to do this and get precise. I like a rough edge sketch, right? It's not to the scale, but you get the picture. Questions on that? How close do yours and I's compare? We good? We jamming? We gelling?
Yep.
All right, good. We're in Dr. Scholl's day. All right, now let's look at this, because this is now taking the bar chart and flipping the data to look at it just a little bit different. Now we are looking at the ages with respect to iPhones, Androids, and what? Others. Now we flip that data to show what? A different view, a different story. Look at this one. This one said others is what? Popular, right? Yep. Yeah, it said others popular. And if we went with that, guess what? Would that be truthful?
Yes.
For this story. Now do you understand how you make the data say what you want to? If we did this, which broke it out in the age group, which is a little bit more clear, it tells a little better story. Look at the age group that is 18 to 34. That's your orange. What do you think, or what would you perceive, without even looking at this? If I said, what is the most popular phone, or most used phone for ages 18 to 34? What would you say? iPhone. Why?
Because it's behind.
Okay, not looking at that, just out of the blue, ask you a question. What do you think would be the popular? iPhone, Android, or something else for 18 to 34? iPhone. Why?
They're more like these ones have got the 9 more local about it. Like you see it more.
It's just what's in it.
Well, it's a little bit more than that. It comes into what is the age that Apple is targeting for their consumer, for your teenagers, right? What is the number one app that makes Apple the most exclusive? Well, Apple's easier to use. It's easier to pick up. Okay? But what app makes Apple more, people say desirable, or makes you fit in more? What app?
Yeah.
Huh? iMessage?
The camera.
We can chat. I can send messages on Android, right? What's the one app? Thank you. FaceTime. See, no other platform has their own. They do. They have like Duo or or Skype or something like that, right? But you would have to have somebody that would have that, right? See, iPhone built that in, that if you purchase an iPhone, it's automatic, right? There's no thing. You can call them, you can text them, or you can FaceTime them, right? Do you see how their marketing went? So now do you see why that's probably a more popular thing? Where do teenagers and people up to 30, 40 years want to be? I want you to look at this one. Look at the middle. Okay. It goes to a little bit down for 34s, right? 35, 54s. And then not so much for 55 plus, right? Okay, let's look at Androids. Androids are more in the 18 to 34. But you said iPhone, right? You thought iPhone, right? But Androids are really, look at the green, the orange right there. See that? Why?
The 30s are getting better.
1834, they're more affordable.
Aren't there more phones that run with Android?
There are more choices of phones, manufacturers that use Android as an operating system. So when you say Apple, you're exclusively looking at one type, right? You say Android, say how it's Samsung, but they make Android devices that are not Samsung, right? What are they? What's more? LG what? LG, right? LG phones are Android, right? So they're more, the pool that uses Androids, their operating system is more. So that would make sense, right? 2, look right here. See, I would have thought that this would have been a lot lower and that the yellow bar for the Androids for that age would have been flipped. I really would. I thought it would have been smaller, but the 35, 54 would have been, because parents like to communicate with their kids. So the most popular phone would have been iPhone, and that you would go that route, right? Not so much. Look at the other. Look at the range that is more receptive for the other. Who are they? Why?
Because they don't play it.
It's a non-smartphone, right? Which means it's what? Flip phone. So you've got to consider some things too as you look at this data. Because see, it's flipped on. It told a different story. I want you to consider when you're looking at things, when did this technology or when did this happen? Has it been a generation? Has it been plugged in recently? Is there like a starting point? Because when you start, your older generation is less receptive to the new technology, right? Because there's a fear there, right? So that doesn't surprise me that there's a greater number of people that use other, because this little device that's called a smartphone scares the bejeebies out of some people. It's too complicated. You got to push something in there. It's like, I can't do it. 2, when they grew up, a phone meant you use it to dial somebody. So that's why a flip phone is used probably more than for people older than 55. Okay, so those are things you got to consider. What was their use of a phone? I grew up with a landline. Cell phones didn't come out till I was in my first, second year in college. And it was the size of a 8.5 by 11 ring of paper with an antenna, and you still had a cord on it, and it looked just like a regular phone. Okay? But it since has changed, it's evolved. So how has things, you gotta look how they evolved, when they were introduced. It tells a different story, right? Same data, but represented how? Different, right? Okay. All right, so that's all of 1, 2. Now, let's get into starting 1, 3 before we go take a break for lunch. At 11:07, we'll go start walking, right? Now, in this right here, you gonna learn how to do a dot plot. You go, I can do a dot plot, Mr. Palmer. It's a number line with a lot of dots on it, right? Now, there's a dot plot. Yep, get her done, right? But we're gonna look at shades, and we're gonna primarily look at three. Now, there's more, but we're gonna primarily look at three. Skew right, skew left, and normal, right? Those are gonna be the three shapes. There'll be more that we introduce, right? But those are three. And then we're gonna look at the distribution of the data within the dot plot. Where's the variability? Those types of stuff, right? How much variation does it have? What does that mean, right? Well, that means how spread your data is. Is it really tight, or is it spread like from here to there? Right? Does it look like a tornado path? Is it from here to there? You don't, that is not tight variability. So you gotta look at that. All right, so take this definition of dot plot. Write that down in your notes, okay? Gotta understand what a dot plot is. All right? Go. I'm gonna stop here on 1.3 because 1.3 needs to have its own video, so it'll pick up on another one. So stop on 1.2 at the end of 1.2.